There's this immense power hidden in the deep ocean. It can travel totally silently, completely invisible, right, across entire oceans. And it's carrying just an unimaginable amount of energy. We're not just talking about a wave here. It's like the ocean itself has been turned into a weapon. So what is this incredible force of nature, and where on earth does it come from? Well, let's dive in.
Just let that sink in for a second. We're not talking about a ripple on the surface. Imagine the entire ocean, from the seafloor all the way up to the surface, moving at the speed of a jet, as one single thing. It's a concept that is both awesome and honestly pretty terrifying. And that right there, that's the key to understanding this whole thing.
Okay, so we've all heard the word tsunami, right? But what is one really? I bet when you hear that word, you're picturing one of those giant curling waves you see in the movies. But the reality? Oh, it's so much more complex and way, way more powerful. All right, so the key is right there in that definition. A sudden displacement of water. This is so important. This is not about wind blowing on the surface, not at all. This is about something massive, something violent, that literally shoves a huge chunk of the ocean out of the way. It's like dropping a giant rock into a pond, but on a planetary scale. And that ripple, it can travel across the entire globe. And this chart, wow, this really lays it all out. Look at this. A normal wave? That's just wind. Its wavelength is what, maybe 100 meters? And it's cruising along at about 30 kilometers an hour. But a tsunami? That's caused by something huge, like an earthquake. And its wavelength? Get this. It can be up to 500 kilometers long. And it's traveling at 800 kilometers an hour. The real kicker, though, is the energy. A normal wave is just a surface thing. A tsunami? The entire column of water, from top to bottom, is moving. That's a huge difference. So you've got to be wondering, how does something this insanely powerful even get started? Well, the birth of a tsunami is never gentle. It's always violent. It's a sudden, catastrophic event that pumps a mind-boggling amount of energy into the ocean in a single instant. Okay, so the number one cause, by far, is a big underwater earthquake, where tectonic plates grind against each other. But other things can do it too. You could have a massive volcanic eruption, like Krakatoa back in 1883, or a giant landslide, but underwater. And hey, even a meteorite impact could do it, though that's, super rare. And here's a super important detail. The key is vertical displacement. An earthquake that just shakes the seafloor back and forth, side to side, that's not going to do it. You need the seabed itself to physically move up or down. It has to either lift that entire column of water above it or drop it. That's the punch. That's what gives the ocean that initial shove. So once all that energy is dumped into the water, the tsunami starts its journey. And this, right here, is one of the most deceptive and, frankly, dangerous parts of its life. Because out in the deep ocean, it's basically an invisible race across the sea. Okay, this next part is going to sound completely backwards. In the deep ocean, tsunamis act as shallow water waves. I know, right? How can a wave in the deepest part of the ocean be a shallow water wave? Well, it's all about physics, and it comes down to ratios. A tsunami's wavelength is just so long, we're talking hundreds of kilometers, that even an ocean that's 4 kilometers deep is considered shallow in comparison. It's a weird concept, but it's exactly what controls its incredible speed. So it all starts with this number. The average depth of the deep ocean is about 4,000 meters, 4 kilometers straight down. And that number, that depth, that's the engine for a tsunami's unbelievable speed. So you take that depth, you plug it into the physics equation, and what do you get? A speed of around 800 kilometers per hour. That is literally the speed of a jetliner. And get this, out there, the wave might only be a few feet high on the surface. It's just racing across the ocean at cruising speed, and any ship it passes under, they wouldn't even notice it. But that invisible race, it can't last forever. As all of that immense energy disguised as this low, fast-moving wave finally gets close to land, a really dramatic and terrifying transformation starts to happen. It's called the shoaling effect. And here's how it works. As the seafloor starts to get shallower near the coast, the wave has no choice but to slow down. It's like it's dragging on the bottom. But all that energy, it has to go somewhere, right? It can't just disappear. It can't go down, so it goes up. The wave starts to compress, and its height just explodes, turning from what looked like a harmless swell into a towering wall of water. And sometimes you get this really eerie thing happen. Before the main wave, the crest, arrives, the trough, the low part of the wave, gets there first. And this causes the ocean to just suddenly and unnaturally pull back, exposing the seafloor. It might look really weird and fascinating, but it is nature's deadliest warning sign. It means the crest of the wave is just minutes away. It means it's time to run.
And when that wave finally hits land, that's when its true destructive power is unleashed. You see, a tsunami doesn't just crash and pull back like a normal wave. It inundates. It just keeps coming, like a fast-rising, super turbulent flood that doesn't stop.
If you want to understand the sheer scale of this, you just have to look at the 2004 Indian Ocean Tsunami. It was triggered by a massive earthquake, and its waves spread across the entire ocean. The result? Over 230,000 deaths across more than a dozen countries. This wasn't just a storm. It was a disaster on a continental scale. And the destruction comes from so many different things at once. First, there's just the pure force of the water itself. It acts less like a wave and more like a river that's just been completely unleashed. Then you've got all the debris, cars, trees, pieces of buildings that the water picks up and turns into battering rams. And then, after all that, there's the backwash, a powerful current that drags everything and everyone back out to sea. So when you're faced with a force of nature that's this unstoppable, it's pretty easy to feel helpless. But here's the thing. Understanding the science behind all this has given us the tools we need to fight back. Not by trying to stop the wave, but by outsmarting it. Which brings us to the ultimate question, doesn't it? After seeing all this, can humans actually stop a tsunami? Could we build a wall high enough or a barrier strong enough to hold back the ocean itself? The answer is a simple, stark no. The amount of energy we're talking about is just off the charts, like thousands of nuclear bombs going off at once. We simply cannot stop it. But that does not mean we're defenseless. So what can we do? We can use science to get ahead of it. We have a global network of sensors that can detect the earthquake pretty much instantly. Then we have special buoys out in the deep ocean that can actually feel the pressure change as the tsunami wave passes over them. That confirms it. All that data gets fed into computers that predict where it's going and when it'll get there. This lets us send out targeted warnings and give people on the coast that crucial time they need to get to higher ground. It really is a race against time, and science is what helps us win it. And really, that's the big takeaway here. We can't build a wall high enough to stop the ocean, but we can build our understanding deep enough to see it coming. The ocean is always going to have this immense raw power. So the real question is, as our planet continues to change, will our knowledge be able to keep pace with the threats that are coming from the deep?